Alright, so tonight we're going to be working backwards, looking at writing an equation of a graph based on what a graph looks like. So to start off, the generic formula for all of our trig graphs is something like this, where A was our amplitude, B, it was 2 pi over B equaled our period, and if it was a tangent or cotangent, it was pi over B equals the period. C here was our horizontal shift, and D was our vertical shift. So what we're going to be doing is looking at a graph and trying to find out what are these four pieces and putting them into the appropriate spot of the equation. So if we look at this first one, and what's going to be key on these is making sure you read the labels on the graph. That's what's going to help you probably the most. So if we start off with something like this, first off, let's go through our list. We have amplitude, period, vertical shift, horizontal shift. So vertical shift, there isn't one because it goes symmetric across the x-axis. There's no shifting up or down. Horizontal shift, well, if we think of this as a sine graph, then there is no horizontal shift. Now, if you thought this was a cosine graph that was shifted, we'd have another story. Go with the one that's more obvious, okay? So even though this could be a cosine graph if you had a horizontal shift, it also looks like a sine graph starting at 0, so go with sine. Your amplitude, so how high up or how far down does it go? It goes 1. And so lastly we have our period. This is the one that it might involve some work. So normally it's 2 pi over B. And the problem is we don't know what B is. But we do know from start to finish our distance here is pi. So then what does B have to be to make this equal pi? So if you multiply both sides by by B, and then divide both sides by pi to get B by itself, you get that B is equal to 2. So A is 1, vertical shift would be 0, and so that would be our D, and our C would also equal 0. So now that we have each letter, and we're saying that it's a sine graph, y equals, let's see, we don't have a number, just a 1, so sine, and then our B 2 times x, and there was nothing being added, so that would be your equation of the graph. Okay, so we're going to do one more for right now, where again we're going to work going backwards and writing the equation. So I'm going to start with drawing my graph. Sorry, this did not come out that great. Okay, so our graph looks something like this. So just like in the other one, we're going to start by trying to figure out our 4 things. Amplitude, I guess it's actually 5. Period, vertical shift, and horizontal shift. We also need to figure out what function we think it is. So because of the part and the way it looks as it's given to us, to me, I would say cosine. Because it starts high, it looks like a cup, cosine cup. So I'm going to go with cosine and write it around it being a cosine. Another issue that I see on this one that's a little different is the fact that it's in degrees instead of radians. So if I convert negative 450 degrees into radians, I get negative 5 pi over 2. And same thing with 270, I'll get 3 pi over 2. And the reason it's going to be helpful to have these in radians is when we go to find our period, now everything will have a pi. And plus our period is in radians with being 2 pi. So from highest point to lowest point is a distance of 6, from 3 to negative 3. So our amplitude would be 3, half of that. We didn't have a vertical shift because it went up 3 and down 3 from 0. So there is none. So that means D is going to equal 0. And so 3 would be our A. Now a horizontal shift, we do have one because normally our peak isn't this far over. So we got to figure out our horizontal shift as well as our period. So how far is it from start to finish? So 2 pi divided by b equals, so to go from negative 5 pi over 2 to 3 pi over 2, we've gone a distance, let's see, negative 5, and so that'd be 5, 3, so 8 pi over 2, which is 4 pi. Multiply both sides by b, and then divide both sides by 4 pi. And we get that b is equal to 1/2. Okay, so now we just have to figure out the horizontal shift. So this point right here would normally have been, if this wasn't shifted at all, over here at 3. So how much did it shift from where it should be to where it actually is now? Well, it shifted negative 5 pi over 2. So we have a left, or you could, this would be where it might be a nice idea to write negative 5 pi over 2 is our horizontal shift. That is our C. So now that we have each letter accounted for, y equals 3 cosine, put your b on the outside, times x minus negative 5 pi over 2. And then we didn't have a d, so we don't have to worry about adding anything on the outside. So the last thing I would do here is to get the double negative into a positive and distribute the 1/2 so that we have everything in just one set of parentheses. So 1/2 x plus 5 pi over 4. So that's after I distribute the 1/2 to both of those. And so this here would be our final answer. So tomorrow in class we're going to do a couple more of writing equations. We'll definitely do a tangent graph because I think we need more practice with those. We also will look at one of the inverse graphs as well to see if we can write that one backwards. So again, if you have any questions, go ahead and come with them, and we can talk about them in class when we go over a couple more examples.